This is lesson 8.6. We're going to learn here how to use the law of sines and cosines to solve problems. It's basically using trigonometry on triangles that aren't right triangles. And so one of the things we need to do is figure out which of these is the most appropriate law to use in each case. So I'll give you 4 examples, and then you can go ahead and practice this on some problems. Law of cosines is best choice if the length of all 3 sides of the triangle are known and you're trying to find an angle. To use the law of sines, you really do need 2 angles or 2 sides and an angle to use that. So here we have all 3. We're looking for an angle. There's a little error here. This longer side obviously shouldn't be 5 if this side is 7 and this side is 12. So we're going to change that to 15. And we're going to use the law of cosines here to find x. First thing we have to do is determine which side is relating to x in this problem. That would be this one, 15, and we always use the sides opposite. And then, so in using the law of cosines, our a right now is 15. Our b and c are the other 2 angles. It doesn't really matter which we put where. And then our cosine of a is the angle x there. So we're gonna use it like this. We're gonna substitute 15 for a, so 15 squared equals, and then we're gonna substitute 7 and 12 for b and c. And then we're gonna subtract 2 times b times c, and times the cosine of angle a. In this case, it's x. And that's in a degree. All right, then to solve that, you're just going to have to simplify each of these and maybe work backwards to find x. In the end, you're going to have to use the cosine inverse function to find x. But probably what you want to do is simplify all of this, subtract 7 squared and 12 squared from 15 squared, and then divide by whatever negative 2 times 7 times 12 is. Then use the cosine inverse, making sure your calculator is in degree mode of that quantity, and that'll give you the degree measures of the angle. You can try it. If you do it all correctly, you should get about 101 degrees. Okay, in case 2, you're going to use the law of cosines again. If 2 sides and an enclosed angle are known, and you're trying to find the side opposite the angle. So these 2 relate, the 87 degrees and the x there. And in this case, we have a side which is x squared. So we're substituting x for a in the law of cosines. Our b and c are 13 and 24, so we're going to 13 squared plus 24 squared, minus 2 times b times c. And these 2 numbers are always the same as those 2 numbers in the formula. And then times the cosine of 87 degrees. And in this case, we can just simplify all of this side, get the value of that, and then that's going to equal x squared. So find that value. Then you can just take the square root of that to get x. And if you do that correctly, you should get about 26.7, and that's not degrees, that's the side length, x. So about 26.7 if we round it to the nearest 10. All right, here's a couple cases where law of sines is best, and in general, you should use the law of sines if you can, just because it's less complicated than the law of cosines. So in this problem, we have 2 sides, and an angle opposite one of the sides is known, and you're trying to find the other angles or angle. We'll just find one of the angles. Of course, once you have 2 of the angles, you can just use the triangle angle sum theorem to find the last angle. But what we can say here now, notice that the side opposite the 115 degree angle is 49, and the side opposite the x degree angle is 16. So we can say that the sine of 115 degrees divided by 49 is equal to the sine of x degrees divided by 16. And then you can use cross products property, and you'll find that the sine of x is equal to the sine of 115 degrees times 16 divided by 49. Then you'll have to use the sine inverse to find the angle of that quantity. And if you do all that right, you will get x is equal to 17.2 degrees approximately. All right, and the last case, case 4, we can use the law of sines again here. If you know two angles of one side and you're trying to find the missing side or sides, we're just going to find the one missing side here, x, and the side opposite x, or the angle opposite x, is not given here. So the first thing we'll probably want to do there is find that missing angle using the triangle angle sum theorem. And so we're going to add 48 and 22 together, and that's 70, and subtract that from 180, and that's our missing side length, 110, 110 degrees, so that's that angle, and that's the side opposite the x. So now we can do the sine of 110 over x, and we have an angle opposite this 15-degree side, so we can use that as our other ratio. Set up the proportion, sine of 22 degrees over 15. Okay, so then to find x, if we do cross product, use the cross product property, we can take the sine of 110 times 15, divide that by the sine of 22, and that'll give us x. And that is, if you do it correctly, you should get about 37.6. All right, we will do the rest of these. You could try some on your own if you want, but the rest are practice problems.